Picking up where we left off, and we're looking here at figure 3 for part 1, or part 1 of figure 3 was just showing you basically where and how to measure these different peaks here. Now what we want to do is be able to show how that Excel, plug it into an Excel spreadsheet. So from our Blackboard site here, I've just uploaded this here for you. That's an updated Excel spreadsheet and template that you can use under your course documents. You can just download that and open it. I'm going to open that with Excel here. That's going to pop that open. And look down at the bottom, you can see different tabs here. Intro, which is the same thing that we used for our last calculations. Frog Skeletal Muscle is shown here. And you can see the different types of graphs that you can actually put in here. Force measurement, you can use this to calculate your different averages if you like. Tension is equal to force. What we're doing here is that we have a couple of things to work with. This is talking about distance from the initial length in millimeters. So the 0 point, in this case, right here, corresponds to where we started off, which is this one right here. That's our 0 point. Plus 1 is here, plus 2, plus 3, plus 4, plus 5. This is minus 1, minus 2, minus 3, minus 4. Okay? So now we go back and we can take that information, we can just plug it in and see what it was that we had as far as our the amount of tension that we had at each of those different time points. And so he filled in some here. Ours might look quite different, but what would happen is as we plug it in, we would change the graph, as you can see indicated there. So your numbers will change in a corresponding way. So this is very useful for you to be able to generate the graph. You can copy and paste this into your Word document to be able to finish for what you need for figure 3. Did you reach the optimal length in your experiments? Asking you basically, did you reach a point at which you reach your optimal length, or did you not? And so part of it's asking you about what it is that's going on. It's overlap between actin and myosin fibers that's important for the contraction force. And so what we have is a slide that's dedicated to talking a little bit about this. You'll want to refer to your 290 notes as well, showing that the amount of tension that you have here shown on the y-axis corresponds to the amount of distance between the sarcomeres. So this little cartoon here at the top is indicating the sarcomeres. The small thin fibers are corresponding to actin, the thick fibers are corresponding to myosin, and the overlap between the two is important for dictating how much tension you can make. And there's an optimum amount of overlap. When you have that overlap, that indicates that you can get the maximal amount of cross bridges formed between actin and myosin, and still be able to have the fibers slide towards the middle to generate a forceful contraction. As you pull the fibers apart and they get further and further apart, they have less of a capacity to actually be able to generate tension, so that even in this extreme example of E over here, what we're finding is that they can't interact with each other at all. Actin and myosin just aren't able to meet. Whereas over here and over here, what's happening is that the fibers are too close to each other, and the actin fibers are actually not able to slide easily because they're starting to bump into the M line that occupies the middle of the sarcomere. So that was a very brief description, but I just wanted to kind of give you a sketch of where to look for it and the concepts behind that particular figure. So figure 4 is looking at the force due to summation, and so let's pull that one out and look at that. We'll look at another group for that, force due to summation. We'll look at group 3, pull it down, and file exchange. Force due to summation. Nerve stimulation, muscle stimulation, tendons. This is it. Yes, I need to save the file. And now I'm going to move it up to the desktop somewhere. That means I have to like minimize all this stuff. This is a better way to do it. Try that one more time over here. There it is. All right. do this one more time. I'm just going to try to get through this. So, yeah. So I tried doing it with Firefox. Okay, now I go here. That should be okay, fine. Now we go back to let's open this up. And there we go. So it's there all the time. Great. Alright, so now I've downloaded this file. Looking at the muscle summation of tetanus. I'm going to zoom out so I can see the entire data set. There we go. Now we can see that entire data set. And we have all of these different hertz. It hasn't been written down here, but you guys went in a very systematic way so you know from your notes what each of these represent. And probably the one that we're going to end up focusing on, if I remember right, is probably one of these where we have incomplete tetanus occurring. So we'll talk about what that means in just a moment. What we're looking at, though, is this force due to summation, generated graph documenting force due to summation at each stimulation frequency. When the muscle is stimulated at a high enough frequency to cause fused tetanus, what happens to the force production of the muscle and what causes those changes? So some of these issues you can see here under the PowerPoint slides. And there's one very important one that I want to talk about here. So here's complete tetanus happening here, incomplete tetanus here, wave summation showing here, and a twitch shown here. And what we're looking at is just different amounts of muscle force that can be generated when we're considering this repeated stimulation of the stimulus continuously through this period here. And so it's continuous stimulation can lead you up towards this complete tetanus until you finally achieve fatigue. So what we're going to want to do is be able to look at this particular type of thing and be able to show how we actually measure the summation due to tetanus. And this is a little bit tricky. What we have over here is, I'm going to zoom in on this area right here, and then zoom in between the two cursors, and we can see that there's very little fusion or summation to tetanus happening here. So what you do not want to do in this case is that you do not want to measure the peak here. Instead, what you're looking for is any indication of summation that's occurring here. So the V2 minus V1 is showing a 0.107 amount here, which is a little bit of summation that's occurring there, but not very much at all. So there may be some summation that's happening here. I'm not seeing it too much. Then we'll just scoot over to the next one, and our next stimulus here. You can see that the twitches are starting to get a little bit closer together. The summation is being depicted by where this line is here, in terms of trying to depict that we're seeing some kind of summation occurring between the different twitches. Not at the peak of the twitches, but in between the twitches. So to help illustrate that, in this case would be 0.103, and you can continue on, but let's go forward up to something like what we see here. In this case, you're looking at the summation due to tetanus, and what you're going to want to do is place this to the, between the last two peaks. And this will give you an idea of how much summation has actually occurred over the course of the entire stimulus paradigm. And so there's our cursor there, and there's our cursor there. Note that this cursor is not here, and it's not here. It's right in between the two. And so that tells us, and that's 1.2323. And so you can note what that is. Once you get those numbers for each of the different forces that you have here, you can put it into your stimulus frequency, which you have listed here under Hertz, and then you can put in your force due to summation and what it came up, and then you'll generate a graph accordingly here that you can copy and paste into your Word document, which is over here. And so you're going to want to talk about what's happening with calcium. And subcellular level, what they're asking you about is they're asking you about what happens to calcium levels and how is it that calcium levels are different in this kind of condition. So subcellular is kind of talking about describing that calcium and how much calcium is there. It's also getting into a little bit about the talking about how the how depolarization results in a calcium spark being created within the cell, or a burst of calcium within the cell as well. And so then when it goes into what muscle is discriminated at a high frequency enough to cause fused tetanus, what happens to the force production? What causes it? In this case, we're talking about thinking about what happens as you start to see the summation of two muscle tension twitches there, and they come closer together. One hasn't had a chance to completely relax before the other one's set in. And so you can look at your notes for more details on that, but that's basically what we're looking at there. All right, so that's what we have here for the skeletal muscle assignment. I hope that was helpful, and I think we're wrapped up for today. Okay, good luck, folks, and I'm trying to figure out how to sign out.